Namaste. Myself Zivin Gaurav from the Faculty of Physiotherapy and Diagnostic in the discipline of Radiation Technology or PHYSIO. Today we are going to discuss on the session X-ray tube or X-ray production requirements. So let me discuss for this session the requirements of X-ray production is first requirement is required source from which the electron is produced. Second requirement is cathode. Second requirement is target to stop the electron. The third requirement is high voltage, high potential applied between cathode and anode to produce the electron. Fourth requirement is to vacuum. Fifth requirement is to insert and housing. So the requirements of the X-ray production. Requirements for X-ray production. The first requirement is source to produce electron. Electrons. Source, other name of the source is cathode. Cathode electrode is used as a source to produce electrons. Second requirement is target anode electrode is used as a target to stop the electron. Third requirements for the X-ray production is high voltage applied between the cathode and anode. Fourth requirement is vacuum. Fifth requirement is tube insert and housing. Okay, these are the requirements or needs for the X-ray production in X-ray tube. X-rays are produced from the target or anode when electron interact with the target material. In the gas tube, target material or anode is made up of aluminum. There is an aluminum stem is present with concave shaped aluminum disc, and the cathode is made up of, in the gas tube, cathode is made up of tungsten or platinum baked in copper. In the X-ray tube, electrons are produced by the thermionic emission and gas ionization. In the gas tube, the electrons are produced through gas ionization, and in the Coolidge tube, electrons are produced through thermionic emission. Thermionic emission or thermionic emission. So these are the requirements of the X-ray production. X-ray production. Okay, electrons are produced through the thermionic emission or gas ionization. So the vacuum is needed less than 10 raised to power minus 5 mmHg for evacuation in the X-ray tube. So it is required, it should be less than 10 raised to power minus 5 mmHg. Okay, these are the requirements. Why vacuum is required in the X-ray tube? The causes is to avoid the collision of electrons with gas molecules. Second cause for the vacuum is to maintain evacuation in the X-ray tube. These are the causes for the vacuum is needed or vacuum required. Okay. The next requirement is tube insert and housing. Tube insert and housing, it is needed for avoid the melting of the target by the heat production. The second is housing or insert is required for cooling the target. So after cooling, the heat is dissipated from the target easily. Tube housing is also required for avoiding the bombardment of an electron in the glass envelope or tube. It also prevent or absorb the undesired X-rays. So the requirement of vacuum and tube insert and housing we have studied. Now we will study about the tubes. There are two types of tubes previously the gas X-ray tube previously or historically gas Xray tube were used, but nowadays Collis tube are used. The gas tube. Now we discuss about the gas tube. Gas Xray tube or gas tube. Gas Xray tube or gas tube. You can see the aluminum stem in this diagram. Aluminum stem. This is a glass envelope. Glass envelope that protect bombardment of electrons. This is the cathode. This is the anode. The charge of the anode is positive, here is negative. So this is the gas tube. So cathode is made up of tungsten or platinum. Cathode is made up of aluminum stem with concave aluminum disc, and anode is made up of tungsten or platinum baked in copper, and the anode is placed in the tube in 45 degree with respect to the axis of the electron. A gas is filled in the Xray tube, so it is called gas tube. Gas is filled in the Xray tube, and a vacuum is required. Required vacuum is less than 0.001 mm of Hg. So gas tube is filled with the gas when electrons are produced by the cathode by gas ionization, then these electron will produce an avalanche by interacting with the gas molecules. And when a gas molecule interact with these electrons, it produces electron and positron. Positron attract by the cathode and electron goes on the target or anode. So in the gas tube there are there are limitations. So we are now using Coolidge tube. In gas tube limitations of gas tube, limitation of gas tubes. Limitation of gas tube is there is an ionization potential for gases that is filled in gas tube is dependent on the evacuation of the tube. When ionization potential is increased, when voltage is increased after ionization potential or beyond ionization potential, the tube current increased enormously and melt the target. So that is a limitation of gas tube. The other limitation is X-ray. The energy of X-ray and intensity of X-ray are interlinked. When we have to penetrate, or when we are required to increase the penetration. We are required to increase the penetration of the X-ray. Then we are required to increase the penetration of X-ray. Then an evacuation or vacuum is required in the then a higher vacuum is required in the tube at a certain or higher ionizing potential. That is the limitations. So vacuum is needed. So we have to evacuate the gas tube after a certain time. So that is the limitations. Gas tube required evacuation. Gas tube has a ionization potential. After the voltage is increased, it melts the target. That is a limitation. And older gas tube and older gas tubes in older gas tubes the gases decreased. After that we have to increase the gases by gas regeneration of gases through outer source. Okay, so evacuation is required, gases refilling is required, and a vacuum is maintained in the gas tube. The third limitation is the electrons produced by the cathode collide with the gas molecules. And avalanche. It produces an avalanche of the electrons. So these are the three limitations of the gas tube. So the advanced X-ray tube were discovered by Coolidge scientists. That is called Coolidge tube. That is based on the thermionic emission principle. Thermionic emission principle. When thermionic emission principle is when cathode filament is is heated to incandescence at a temperature through applying higher voltage. Through applying a voltage in the X-ray tube, it produces electrons, that is called thermionic emissions. Thermionic emission principle. All the modern X-ray tubes are based on the thermionic emission principle. Like two types of anode X-ray tube are used in nowadays. First is stationary anode X-ray tube and the second is rotating anode X-ray tube. Stationary anode X-ray tube. In the stationary anode X-ray tube, the anode is stationary. Anode is stable or stationary or fixed at a position. In the rotation anode X-ray tube, the tube is continuously rotating. Anode is continuously rotating to avoid the melting of target. So the rotating anode X-ray tube is an advanced X-ray tube that is used in higher imaging modalities. So the session is over. This session is powered by PHYSIO version 2.0, Jyoti Vidyapeeth Women's University, Jaipur. Thank you.